afternoon. Thanks for choosing Pyramid of Refactoring in this slot. My name is Wlodek. I run a company that provides code quality trainings. Mainly these trainings are aimed at improving code quality through different techniques of refactoring. In the past, I was working for about 20 years in different companies. At the beginning as a developer, as a junior one, then more senior one. At some point, I became a team leader. And throughout these almost 20 years, I was observing different struggles with code quality, from inside of the team, from the outside of the team. A few years ago, I started providing refactoring trainings. And this experience, talking to lots of developers, and also making my own thoughts about the different refactorings that I was performing, I was teaching, lead me to a point that allowed me to create this talk now, to notice the concept of pyramid of refactoring. What is it? It is something that lies between the main two books about refactorings. In fact, there are not that many books about refactorings. These two are the most common ones, the core ones. The first one on the left, by Martin Fowler, have a look at it, was published 20 years ago. Last year it was republished. Martin Fowler has rewritten all of the samples into JavaScript to make it easier to understand. But this book is a kind of a catalog. At the beginning it contains about 40 pages of different samples, of a single sample that is refactored. But then it contains about 300 pages of different refactorings as a catalog. So this book is a kind of encyclopedia. And when we have a book that is a kind of an encyclopedia, a kind of catalog, then the question comes, is it doable to learn how to perform refactoring from encyclopedia, from a catalog? To make the answer to this question easier, let's imagine that we want to study English, and we have Longman English Dictionary, where English words are explained using other English words. Is it doable to use such a dictionary to learn English? Yeah. The answer is it depends. It depends on what? On our level of English. If it's quite high, it will be useful. If we are beginners in English language, then most likely such a dictionary will not be that useful to us. And that's the issue that I see in case of this book. The second book that was published a few years later took us with the subject of refactoring much further. It contains about 26, 27 different samples of refactorings towards different design patterns. But in this book, the samples are already prepared to go from a certain smaller or bigger mess, legacy code, towards given design pattern like command, strategy, factory, state, and so on. And then next question comes to my mind. Is it easy to use this book in our daily work? Because usually we do not see very easily that we could refactor given piece of code towards given design pattern. Then one more book, third book, from the core books comes, Working Effectively with Legacy Code. And if you do not know at all how to start with, when you are dealing with legacy code, it's good to have a look at this book because it might bring you some ideas. And between all these three books, especially between the first two, I found something that I called pyramid of refactoring, a kind of a concept. Let's have a closer look at this one. So it is a pyramid. And if it's a pyramid, it contains layers, levels. And as you see, the upper levels are based on the lower levels. And this means that you can't think or you can't refactor at higher levels if you skip lower levels. The first level is the flow. If you have a method that contains 1,000 of methods, a waste bin of local variables, nested conditions, nested loops, then the first thing would be to understand it, of course, to add the missing tests that are covering this behavior, to be sure that we won't break anything. But you can notice a lot of things. For example, in case of legacy code, a lot of methods might contain a single exit point at the end. And if it is the case, then most likely such a method must contain a big set of local variables to keep the state of the logic, what's happening between, finally, when you reach the last line. So maybe introducing a few more exit points, a few more return statements into such a method would solve the problem. And this way, we can get rid of a few local variables. Maybe a loop is too big, so maybe it could be replaced with 3 smaller loops, and the content of each smaller loop can be extracted into a smaller method. And this later, such 3 loops can be replaced with a stream. So once we deal with the basics, the flow, and once we make the flow more readable, then most likely things that are connected will be next to each other. And these things can be put into smaller methods. And then the original big method becomes a smaller method that calls low-level details methods, so we can understand the skeleton of the logic, what's happening. When you have smaller methods, we can move these methods around classes. Maybe a given method should be put into a different class because it uses extensively data that are present in that class. This way, we can shuffle with the methods, move them between classes, or sometimes we extract a new class, because it might happen that a class contains a set of fields, a set of methods, but we can divide the methods and the fields into 2 sets that are using separate fields and separate methods. Or maybe 2 classes share common content that can be extracted into common base class for these classes. This way, we will have more classes, and these classes will be smaller and smaller. And we can think at this point about interactions between these classes and hide these interactions behind interfaces or behind abstract base classes. But have a look, this is the 4th level. Very often we complain that we would like to have a set of strategies in our baseline, in our base code, or we would like to have a state design pattern. But if we do not start from the bottom and continue by extracting smaller methods, it will be impossible to reach the level of the patterns. And finally, when we have a set of classes, a set of interfaces, we shuffle, we move them between different packages, maybe between different modules, between different libraries. And this way, we deal with the level of architectures. But it is not the case that each day we change the architecture. Definitely not. But each day, we can extract smaller methods, smaller classes, simplify the flow. Refactoring pyramid is a twin, brother, or sister. In Polish, it would be sister of testing pyramid. Why? Because if you want to perform refactorings at given level, you need to have a test coverage at the same level. So if it is the case that there is one method and one test, one class and one testing class, it will be very tough to change a bigger picture of classes. But if we have integration tests or component tests that are covering a certain area of functionality, like 15, 20 classes, then we can much more easily refactor a whole area of classes. Okay, let's finish talking. And I would like to move into live refactoring. In a minute, we are going to see a project. The project will be a very simple code that is used to look for properties. Look for properties based on certain conditions. Maybe we are looking for a wooden house in a village. Maybe we are looking for a flat in a big city. Maybe we are looking for a stone, a castle built using stone. So there will be many different conditions, as you see, like the material given property is built on, the building area, the placement, the type, maybe it's a house, maybe it's a bungalow, maybe it's a castle, maybe just a flat in a block. And here we can see original, maybe not original, legacy, that's the better word, legacy class, real estate finder. Just historically, a few methods were added here. At the beginning, the first requirement was that we are looking for properties that are not bigger than certain amount of square meters. Next condition came later, that we want to be able to find all wooden or properties that are built using bricks. Next, we have a join of these two conditions. So I would like to find all wooden houses that are not bigger than 120 square meters in a small village. And so on and so on. Have a look. And very often it is the case in our teams that we do Control-C, Control-V, copy-paste, because it was designed like this. Yeah? What would happen if there is a requirement that I would like property, real estate, to have one more field? This will be true, false. Does given property contain a lift, an elevator? Yeah? Then you hear, okay, Wlodek, everything is ready. It's just such a small change. Yeah? Everything is ready, everything is there. Just add condition to be able to search by presence or lack of presence of a lift. Yeah? And then one more method is added. Maybe here it would be 6th method, but maybe in reality it will be 51st method. And what happens? Yeah? This happens. It's not me, it's the team. It was like this. This was the design. I'm following the design. So why anyone is complaining that I did something wrong? Then this class is bigger, bigger, bigger. So what can we do? Let's have a look at the real code and perform some refactorings. Is it big enough to read, guys? Okay, because, okay, so it looks like we don't have to use presentation mode. Let's have a look. We have a coverage of tests. So we have a test that contains wooden bungalow in a village, wooden house in a village, a small house in a town made of bricks, a small bungalow made of bricks in a village, and so on. And we have a test coverage, so we want to find small properties. We have a test that can check what are the properties in our catalog that are smaller than 70 square meters. What are the properties that are wooden, made of wood? What are the properties that are wooden and quite small? Here is the finder. So it contains methods. Just historically, our developers stopped at Java 1.4, as you see. Have a look. It shouldn't be B, sorry. Shift F6. It will be by, below area. By, we are searching for small properties. Or we are searching using the material. What is the only difference between these two methods, regardless of how old the loop is created? Here is the difference. The condition. The condition is, here is one condition, here is the second condition. And moreover, even if I mark it, and let's extract it into a method. Command-Alt-M, so it will be matches. The first method that I have extracted. Okay. It's, where is it? It should be here. We've got it. What happens? If I have such a method within this loop, then I can have a look at the method and see, in fact, max building area is always the same. A state, the property, is always different because it comes from the loop. So maybe I could think about putting this logic into a class. Let's create such a below. It will be below area spec. Below area spec is equal to new below area spec. Okay, let's, as I see that max building area is always the same, it will be a field. Alt-Enter, create class, enter, enter. We've got the class. Let's create a field, create field. Let's create, and let's create a getter. Why? You will see in a minute. Not a rocket science, nothing special, just a class that wraps the number of square meters, which is our limit. But have a look. I would like, my goal would be to put this method matches into below area spec, into this class. How can I do this? This method takes two parameters, the square meters and the property. But what if I extracted this method again? Let's get rid of this method, inline it for a while, and let's replace max building area with below area spec dot get max building area. This was the reason I added this getter. What will happen if I now extract a method out of this condition? Let's do this. Matches. Do you see? The parameters of the method now are different. The second parameter is the same as it was, but the first parameter below area spec now is different, which was in fact my goal. Keep original signature and please have a look. Now I have a method that takes two parameters, but I can move this method easily, automatically, into below area spec. Now the first parameter is gone, only the second parameter remained, because the first parameter became the class itself. And moreover, now I think, okay, it sounds good, because I will create this specification only once. I will call this method with each different property coming from the loop. And now I see, so maybe most likely I could create such classes for the other conditions. And if it's the case, then most likely these classes should share an interface. The same for each of them. Now maybe matches name is not the best, so let's rename it into am I satisfied by this property? I am condition, am I satisfied by this property? So let's think about the interface. We can extract the interface very easily. There is a menu that allows us to extract interface. The name of the spec will be, the name of the interface will be spec. Oh, something is missing. What is missing? I wanted to put this class into an interface, but it is not public. How to make a method public? In IntelliJ. Type public. That's one option, yeah? But we have more options, like Alt-Enter, make public. It's public. Now I can extract the interface. Extract interface. It will contain this method. The name of the interface is spec. Click refactor. And see, we've got a pop-up. What this pop-up says? It says, I am IntelliJ, a very intelligent IDE. And when you are extracting an interface, I can search throughout the whole project, your whole legacy code. And I can look for parameters, returning values, fields, local variables. And if I find a case when the code still compiles, everything works, then in such a case, I will replace the class with the interface. Let's do this. Click yes. Do you see? That's the line. I'm not sure how visible, but in this line, it found this line where the type of the variable will refer to the interface instead of the class. And it has a question, would you like me to rename it so the name of this local variable is referring to the interface, not to the class? Let's click yes. I would like it to be done. Let's click do refactor and have a look. it is here. Yeah, now it is interface. But moreover, okay, let's deal with the flow a little. While Alt-Enter, replace with for each. What's next? Alt-Enter, replace with collect. Okay, we came from Java 1.5, 1.4 to 1.8. Found properties. Do I need this local variable? Does it bring any value to me? Most likely not, so I can inline it. Okay, so we are returning repository .stream .filter .collect. And we've got the specification. And now I can see again, maybe, most likely, this is a code that searches throughout the repository of available properties and checks the conditions. So maybe I could mark this and extract one more method out of this called find by spec. If I do this, have a look. I've got one more method. Currently it's private, let's make it public. And maybe this one should be marked as deprecated. Please do not use it any longer. Now I can think, do I need really this local variable? Does it bring any value to me? Most likely not, so let's inline it. And now the first method, searching up to certain amount of square meters, is calling my new, brand new, by spec method. I can do easily similar thing for by material, but I would like to do this slightly differently. What can we change? Here is the condition. Yes? So I can inline this condition again into is satisfied. Is satisfied by. Yes, I've got it. Okay, replace it in all other places. I've got, this is my is satisfied by. I know that I should get rid somehow of the first parameter, but now, before we created this class manually, now we will extract it using IntelliJ. We've got refactor this, extract, delegate. Let's mark it. It will be material spec. Okay, I've got it. This single method is satisfied by, goes into this method. Let's click refactor, and let's have a look. I've got it. It was created. Nothing special inside it. Empty constructor. But what can I do? Let's come back to Finder, and let's continue. Material spec became a field, which is a reasonable behavior when we are extracting a new class. But for each case, most likely, I will need different material spec instance. So let's inline this field for a while. Inline all and remove the field. Let's have a look. It is present here. Okay. This most likely this code will be present in a few other places because I have extracted a single method out of code that was repeated throughout my class. So let's extract it into one more method. Is of material. Is of material. Let's click enter. Replace in all cases. I've got it. It is here. Cool. And now I know that this constructor is called only in single places, only using this method, because I have created it. So what we can do, let's click, do you know the shortcut? It is Control-C, then it's Control-V. Do you know this? And then Alt-Enter, add material as first parameter. I've got it. It is here. Alt-Enter, create field. We've got it. And now I can put here 1, 2, 3, 4, 5, 6, 7, 8, 9. Why have I done this? What's happening now? We've got the field, that contains the same value, the same reference. So the parameter is not needed. If you click Alt-Enter, then you've got save, delete. The parameter is gone. It's a simple, of course, it's a very simple here, but imagine that this method would be called from 100 places in your legacy code. Within a second, 100 places have been adjusted. Oh, this method now should be Alt-Enter, make public. It should implement the interface, implements spec. Okay, we've got it. So what now do we need? Have a look. Is of material, I will inline for a while this method. I will mark is of material. I will extract a local variable out of this. I will put it at the top. I've got my spec. And what shall I do now? Now I can get rid of the remaining lines. And here I can put return by spec, which is material spec. And this way, I can also inline this local variable. And my second method, of course, it will be deprecated because I would not like that anyone follows this pattern. But currently, maybe let's assume that it is called from lots of places in our project. But let's have a look at the packages. We have one interface and two new classes that have been created. And in such a case, there will be most likely more and more classes in the same package. So maybe we could think about introducing one more sub-package called specs, for example. And into this one, I would put below area spec and material spec. Let's put them here. And let's see what we've got. OK. Now, a few other things can be done. And spec, have a look. Is satisfied by here, it is not used. We've got by spec, and here we've got by material and below area. So what shall we do? Let's create an end spec quickly. Here is, sorry, to save time, I'm just copy-pasting. But in order to have end spec, here is what we need. Alt-Enter, introduce local variable for this occurrence only. Alt-Enter, introduce local variable. OK, we've got. And what we need? We need end spec. End spec is equal to new end spec. That takes what? Below area spec, and the second would be material spec. We've got it. The class doesn't exist. If you click Alt-Enter on the constructor, it will create the class together with the constructor. The constructor is not taking the implementations. It is taking left spec and right spec. Right spec. OK. We've got the constructor. What is missing? The fields. Let's create them. Let's create two getters for a while. And now when we come back into Real Estate Finder, what can I do? Here, this one can be replaced with endspec.get left. The second one will be replaced with endspec.get right spec. Dot is satisfied by estate. OK. What's next? Once I mark this condition, I can extract it into one more method called isSatisfiedBy. And as you see, this method takes endspec as the first parameter and real estate as the second. If I have such a method, I can easily move this method using F6 into endspec. I've got it here. Now I don't need this getter. I don't need the second getter. I can inline them. Endspec, again, can implement spec. And this method should be public. Let's come back for a while and put endspec into the specs. Why have I done this? As you see, I'm putting these two together because the interface is the contract. The contract defined by real estate finder. It's the real estate finder that says, if you want to talk to me, implement the interface and provide it. And have a look. What can we achieve in such a case? At some point, real estate finder might contain only a single method find by spec, the interface. And we can extract terminal specifications like material spec, below area spec, and we can extract non-terminal specification that will be used to build the whole query. Moreover, what we can achieve this way, have a look. I have put here as a sample below price spec. Below price spec needs to call external service using, let's say, some REST API and get the newest price that currently is assigned to given property. If I don't do this, price DAO needs to be a field within real estate finder. So at the beginning, quite soon, we would end up with real estate finder having a waste bin of fields where a single field is used by a single method. Now, if we go towards this design below price spec, then this class contains all the fields that are required and not any more. So what have we done? How solid refers to this? I think that during what we have done, I want to come back in a minute to a little more live coding to show you even more tricks. We are climbing up towards the top of the pyramid. We started with the flow. I admit we have not done too much refactorings with the flow because dealing with a messy flow would take us, I guess, the whole talk. But when we dealt with the flow, we extracted methods, smaller classes. We extracted the interface. And also we dealt a little with the architectures because we are moving the classes between different packages. So we started with single responsibility principle. Below area spec, material spec, these classes definitely have single responsibility. Even product finder has single responsibility because it is responsible for searching through the catalog and returning only the properties that fulfill the requirements. Then we extracted interface. So interface segregation principle was also fulfilled. And only when we finished dealing with single responsibility principle and interface segregation principle, we could think about open-close principle, because product finder now contains find by spec method, and this method takes interface. So finally, at this point, product finder is closed for modification and opened for extensions. And later, at the top, we could deal with dependency inversion principle by putting different things into different packages. Product finder and specification interface are together within a single package, whereas color spec is in a different package. Why? Because it might be provided in different modules, maybe by different teams, through different libraries. So as you see, solid principles can be put very nicely onto the pyramid. You need to start with single responsibility if you want to go up and be able to climb up towards the top of the pyramid. We skipped Liskov substitution principle. It wasn't present in this sample, but this rule, usually breaking this rule happens when you have incorrect inheritance. So replacing inheritance with a delegation would be something that happens at the level of classes. So have a look, pyramid placement. How it feels between two main books. The first book is a catalog, an encyclopedia. So each sample, each of 70, 80 samples taken from this book can be put somewhere on this pyramid. If we have extract local variable or replace loop with a stream, these are refactorings that are happening at the lowest level. If we are extracting methods, changing parameters in these methods, it is happening at level of methods. Then we are extracting classes and so on. But each sample taken from refactoring to patterns book is like going through the pyramid. Let's take any other sample from this book. For example, extract, do refactoring towards strategy. If you have a big class, a big method, extract a few smaller methods. You've got a few other methods extracted. Put each of these methods into a separate class. Next, rename these methods to share common interface. Extract this interface. Make each of these classes implement the same interface, and you have a set of strategies. And climbing towards the top of the pyramid is present in the majority of, in all big samples. There are a few smaller samples where only part of this pyramid is covered. So if there would be only, if I was asked to choose a single slide to remember, this would be this one, definitely. Pyramid of refactoring that joins these two books. It is not mentioned in any of these books, but definitely I see that this concept is present. Okay, in a minute we'll jump into a few organizational things that I would like to cover as well, but I would like to show you one more trick. Because so far, when we are performing our refactorings, it's real estate, okay, it's here. For this one, we created below area spec manually. For this one, we used extract delegate. But there are a few more tricks in IntelliJ that you can do. So, okay, we've got end spec. Sorry, here I forgot to put return by spec and spec. Most likely, I do not need this local variable. We can put here that it is deprecated. But by placement, I would like to do one more trick. Here, let's extract this method again. Is satisfied by. Is satisfied by. I've got it. Replace in this. Okay. Where is it? Is here. Again, I would like to put is satisfied by method into my new class that would be called placement spec, because here we check if given property is placed in a city, in a town, or in a village. So what can I do? I've got so many tricks. Let's use one of them. Let's click on the placement. I can extract functional parameter in IntelliJ. Let's extract it as a supplier. Enter. The name will be currently placement supplier. And I've got it. It's here. I've got anonymous class. But if I click F6, then I can extract a class that implements this interface, so it will be called my placement spec. I've got it. It is here. Okay. Now, my method, where is it? My method called isSatisfiedBy, my method, takes strange parameter supplier. But I would like to change the second parameter from the interface into the class. Let's run change signature. Here I can replace the supplier with placement spec. Let's mark delegate via overloading method. Let's click refactor and have a look what happened. This method, the original method, is not used any longer. Compiler chooses the second one because it is more appropriate. So in such a case, this one is not needed at all. As you see, sorry, what happened? Okay, I made one mistake, sorry. Let's comment this out. As you see, this new method would not be used. Let's delete it. And my new method is used. But my new method takes, as you see, placement spec as a second parameter. So I can easily move it into my new spec. It implements the supplier, but it is not needed anywhere in the project, so I can get rid of. It has a getter that currently I can inline. I can add implements spec once is satisfied by method is public. And I can move it into upper level as such, make it public. Let's do this. And again, I can move this spec into my set of specs. So we did 3 tricks. Yeah, we created the spec class manually, we used extract delegate, and we achieved exactly the same through extracting parameter. And as you see this way, we can restructure the code into final version that would look like something like this. Have a look. We have a set of specifications, and here it's only the finder and the interface. And the tests should be green. They are not. Why? No such method error. Oh, I have commented out one of the methods. That's true, but it is in the interpreter. But in the final result, everything is green. Sorry, but that's live coding. So I do provide technical trainings, and I teach people technical skills, but very often, technical skills are not enough. They are half of the success. Very often we attend a workshop, attend a training, a conference, we see a nice talk, and we think, wow, I would like to introduce this into my team. I'm so enthusiastic about this. The second day looks similar. The third day, my enthusiasm is smaller after a week. Yeah, we come to previous months, previous years. There is no refactoring, not too much attention to code quality. Life is life, and so on. So what can we do? Once we have this enthusiasm about new things, let's review what are our skills within the team and what we want to learn. What would be the plan to learn new skills, to share this new knowledge? And this way, we can balance between emotions and mind. When we have a lot of emotions, we can prepare a plan for the times in the future when the emotions will go down, but this plan will allow us to learn new skills. A good example is one of my teams when we introduced refactoring sessions. Every week, Wednesday, 2 p.m., there was a refactoring session, 1 hour and a half. We are choosing a piece of code that we indeed hated, we didn't like, and making a brainstorming what to do with it. But sometimes it happened that I was really exhausted at 2 p.m. on Wednesday. But then my team was taking me to the room because it was Wednesday, 2 p.m. And it is very good. Anyway, Control-C, Control-V, copy-paste is not that bad. Because have a look. Previously, the original project would be extended by making more find by something methods. But when we have the new design, okay, maybe for some time people will say, okay, it's not me, it's the team, this is the design, but automatically new implementations of the spec interface would be provided. So it's not that bad. Sometimes it's good to think how to make use of our comfort zone that we do not, very often we do not like to take risk, we avoid risk, we prefer to have safety place in our work, and we just do copy-paste approach. It's good to look for, it's good to also to look for things that can trigger refactorings. For example, code review. Have a look what code review is used for in your teams. I visited a few teams as a trainer, and I could see, for example, in lots of teams that code review was nothing else as hurry up, is it good enough, go to production with this code. But maybe code review should be used to check if given piece of code is readable, is testable, requires something add, requires more discussions. Moreover, what I do really emphasize and suggest is avoiding local hierarchies in the team. Because if it's only principal, senior principal, developer, our architect that does the code review and accepts the changes, then most likely the other people will get rid of responsibility. Because they think, okay, maybe I have created this, but our principal developer accepted this change. So why anyone is complaining about the code of about the quality? If every person in a team is equal, and I have right to complain about some things, and I know at the same time that I will be assessed by the other members of the team in the same way, then most likely I will be much more responsible, much more empowered to take care of code quality. To make it happen, it is very good to put things like code review or refactoring, rework into your Kanban board or Scrum board. Have a look what happens if you don't have these two columns. I have seen this so many times. In queue, in development, in testing, done. So if you have such a board with only 4 columns, to do, development, testing, done, where is refactoring? Maybe in development column, maybe in testing, but it is not official. If it's not official, I have to hide it. I have to add a few more hours to development to perform refactoring. But if it's not official, then most likely it will be performed in a hidden way, or it will not happen at all. Why? Because people that are not doing any refactorings anywhere will be promoted. They will be faster for some time. If you are not assessed by the quality somehow, and it is not built into the project, then most likely quality things, quality actions might not happen. So, and this way, by joining these two things, by showing you the pyramid of refactoring and trying to trigger you how to add quality actions into your projects, I wish you good luck with the pyramid. So that's it. I'm here for the whole day, tomorrow as well. If you have any questions, you can find me today in today's party. Good luck with your refactorings. Thank you.